Good morning. It is Tuesday morning, March 24th, and I was going to spend a few minutes going over the answers to the questions from yesterday's assignment. Thank you to everybody who's been participating. It's not mandatory, but it sure does help keep your mind active and learning. So thank you to those of you who participated. At the time of this recording, it's this morning, so I'll check at noon to see who all's participated, and I'll record that as part of our way of keeping track of who's staying up with us. And once again, do your best. These problems are hard, and I'll work through them. And it's just a matter of learning what we don't know. Okay, so number one, this is from a math competition actually called Math Counts, and this particular portion is a sprint round, and it's usually done head to head. So some of these problems are actually really easy, but also keep in mind that these answers are usually done live, and they're usually answered within a few seconds using mental math, but you are allowed to use a calculator. So number one, according to the ruler, how many centimeters long is the piece of washi tape shown here? Now, it starts, I'm going to use my stylus, starts at 12 and it ends at 24. So that leaves us with 24 minus 12, which gives us 12 centimeters. So number one should have been 12 centimeters. Okay, erase this. Number two, pretty easy. What is the tens digit of this sum? Well, just for time's sake, just do it algorithmically. So 5 plus 9 is 14. Hold on. 14. And then we have 1 plus 4 is 5 plus 8 is 13. We're going to leave the 3 right there and carry that 1, which means that the 3 is the digit in the tens place. We don't even have to finish it because it only asks us for the tens digit. Okay. Moving on, number 3. This one kind of tripped me up at first because my son and I were doing this for speed, and he quickly said the answer was 8. And at first look, it says, yeah, Dora drinks a 12-ounce can of cola. Erica drinks blah, 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 20-ounce bottle of cola. But if you look, it says that she drinks half of a 20-ounce bottle, which means that she only drank 10 ounces. So if you look really closely, Dora actually drank more than Erica because 12 minus 10 equals 2. And the answer would be 2 ounces. Okay, hopefully you got that one. Erase this really quickly. I'm using my computer in tablet mode for the first time, so it's kind of interesting. Number 4. What is the result when 128,000 is subtracted from 1 million? Well, if you do that algorithmically, which I'll do really quickly, we have 1 million minus 128,000. Oh, I think I made too many zeros there. Forgive me. That was 100 million. Here is 1 million. 1, 1, 2, 3. 1, 2, 3. And we're going to subtract 128,000. So 128,000. Okay, a lot of you should be able to do this mentally. If you take the 100,000 away from a million, you have 900,000. You take 28,000 more off of 900,000, and you should get 872,000 as your answer. There you go. Okay, moving on. Let's take a look at number 5. I get a little sloppy here because I'm not getting it all erased. Okay, number 5. What is the side length of a rectangle that has a width of 7 inches and an area of 105? So if we take 7 and we multiply it by this missing length, which we'll call P is 105, then how do we find the value of P? Well, we find the value of P by taking 105 and dividing it by 7. Now, I know that 7 times 10 is 70, and that leaves me with 35 more. Now, 7 times 5 is 35. When you add 70 and 35, you get 105. So that leaves me with 15 times 7 being the answer to get 105 square inches. So your answer on that one is 15. Okay, we're getting a little tricky here. This next one is, what is the integer closest to -7 times pi? Now, fifth graders have discussed this before with the fact that whenever you multiply a positive number times a negative number, you always get a negative. If you multiply a negative times a negative, you get a positive. But then, if you take a positive, which we all know, times a positive, we also get positive. So in this case, we have a -7 and a positive pi, which hopefully everyone knows is 3.14. Now, for the fourth grade students who haven't covered multiplying using decimals, we can do this algorithmically really quick, or you can just do it on the calculator, but let me go ahead and do it algorithmically. I'm going to go ahead and put the 3.14 on the top. 3.14 times 7. Okay. So 7 times 4 is 28. Carry my 2. 7 times 1 plus 2 is 9. Okay, 7 times 3 is 21. Now, I'm not multiplying 314 times 7. I'm actually multiplying 3.14, which means that I actually need to divide my answer by 100 in order to get the correct answer, which leaves me with 21.98, but 21.98 is not an integer. An integer has to be a whole number, meaning you have to round it to the nearest one. So if we round this to the nearest one, our answer would be not 22, since we're multiplying it by -7, our answer is -22. Okay, let's take a look at number 7. Once again, we're dealing with negative numbers. It's not a really hard concept, but it's a concept that we start running into a lot, especially in 5th grade, as we take STAR assessments that demand us to know a lot more about negative integers. So, start off with our number line here. We have -17 as our starting temperature. And it says between 8 p.m. on Monday and 6 a.m. on Tuesday, the temperature increased 23 degrees. So I'm going to count up 23 degrees. And if I make this number line here and I count up and I get to 0, that's counted up 17 degrees. Or sorry, so we're increasing by 23 degrees. So I need to count up by 23. Okay? So we count up 17 to even get to 0, which leaves us with 6 degrees on the positive side. Okay? So pot's +6. Now, on Tuesday between 6 a.m. and 3 p.m., the temperature decreased by 5 degrees. So from 6, we count back 5, which leaves us with 1 degree. It was 1 degree on Tuesday at 3 p.m. Okay, moving on. This next one, once again, I think the 5th graders are much more prepared for this since we have been discussing percent, but 4th graders can take a look at it as a preview of what we'll really focus a lot on next year. This one says the table shows all 5 lunch options on a Friday at a middle school and the number of students that ordered each lunch. Based on this, what percent of the lunch orders on Friday were for spaghetti? So what we have to do first is we have to find the total. So if we add up all of these numbers, we actually get 400. Okay? Of those, 44 of them were spaghetti. So this is our fraction. So we can convert fractions into decimals, and oftentimes we do first of all convert our numbers into decimals and then convert them into percentages. But percent means per 100. This one's really nice because we can reduce it. If we divide both of these by 4, 44 divided by 4 is 11, and 400 divided by 4 is 100. So per 100, we have 11. So in this case, our answer is 11%. That was tricky. There's going to be another one on the assignment today that's going to be a lot like this. Okay, let's erase this. Okay. It's not as fun when I don't have you guys asking questions and answering questions, but we get by. Okay. What is the 40th positive odd integer? Remember, integers are whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9. But fractions are not integers. Decimals are not integers. It has to be a whole number. Now this one's tricky because it's every other number is odd, obviously, and every other number is even. In this case, if you count up, you actually get the answer of 79 being your 40th positive integer. Now, the actual formula for this, which you could apply with larger numbers, would be that you take the number, the place number, in which case this is 40, you multiply by 2, because it's every other one, but for odd numbers, you actually have to subtract 1. So if you take 40 times 2, which is 80, subtract 1, you get 79 as your answer. Okay, now I know a lot of you had problems with this last one. Once again, division of fractions is something that my 5th graders have been working on, but we have not done many fractions within fractions. So let's take a look at this really quickly. Now, what we have to do here, first of all, we find the value of this expression. It is an expression because it doesn't have an equal sign. What if I did this? This might make it a little more clear. We need to do this quantity first. Okay, so if we take 1 minus 2/3, it gives me 1/3. So that leaves me with 1 plus 2 over 1/3. Okay, now we know that a fraction is nothing but a division problem. So the numerator in this case could be put into an equation like this. 2 divided by 1/3. Now this is ahead of the 4th graders, but just hold on. So 2 is the same thing as 2 over 1. Now we know that whenever you divide by something, it's the same thing as multiplying by its reciprocal. So the reciprocal of 1/3, we just flip it upside down, leaves us with 2 over 1 times 3 over 1. And, the algorithmic way is we just multiply straight across, which leaves us with 6 over 1. And if we add 6 over 1, which we know is 6, to 1, the answer is 7. Cool problem. I like that one. Also, you could think of it as I have 2 cups of flour, and my recipe calls for 1/3 cup for each batch. How many batches can I make? How many 1/3s are there in 2? In this case, it's 6. You add the 1, and it gives us 7. So hopefully that makes sense. You can always ask me questions if it doesn't. I want to go over the answers to the mystery signs. It was a really cool video on, how do mountains become the shape that they are, and what is the difference of the rocks at the top compared to the bottom? Well, do mountains last forever? No, they do not. they, over time, began to break into pieces. This first answer says less sophisticated, meaning that this doesn't give very much detail. In this case, no, they break into smaller pieces. But a more sophisticated response is that the rocks break into smaller pieces and they roll down the mountain, and eventually the mountain becomes more rounded, and it eventually will not be there over many millions of years. Number two, how does solid rock break into smaller pieces? This is a really cool concept too. It talked a lot about seed wedging and water ice wedging. So basically what that means is seeds fall into the crack, they continue to grow, the roots expand, and they break the rocks apart. And they take larger rocks, breaking them into smaller pieces. Same thing with water. As water freezes, it expands. And the expansion and contraction of water within cracks of the rocks break them into pieces, and they tumble down the mountain, and that is how it's broken into smaller pieces. Okay, and then finally, how are rocks at the top of the mountain different from the ones at the bottom? Well, you would recognize this if you were a mountain climber, but when you get towards the top of a mountain, the rocks are really sharp. But at the bottom, they're more rounded and smooth. And the reason is because as they fall off, as they're broken off the mountain and they fall down the mountain, they lose their edges by tumbling. Sharp corners come off. Towards the bottom of the mountain, there's a lot more water runoff, so there is the effect of water eroding at the corners of the rocks. So the rocks at the bottom are going to be more rounded and smooth. The ones at the top are going to be more sharp. So keep an eye out for your Google Classroom assignment today on an extension to what we did yesterday with Math Counts, and another mystery science video on landslides. I might be transferring this all over to Google Classroom rather than using Formative. I had a problem this morning with accessing Formative. So keep an eye out for any format changes. It might just be simpler if I issue you the Google Doc and then you submit the Google Doc within Google Classroom for me to see your participation. So always feel free to email me. If you have any questions, please do so. And I hope everyone is well. We'll see you soon.